My name is Megan Ziegler, and today we're going to look at action potential. An action potential is where there is a change in an electrical potential associated with the passage of an impulse in a nerve or muscle cell. But to explain what an action potential is, we have to look at where an action potential takes place. It takes place in a specialized cell called a neuron. A neuron is a nerve cell that is a part of the neural tissue, and it transmits information to other nerve cells, muscles, or gland cells. A neuron has many different parts, which include a cell body, a nucleus, dendrites, an axon terminals, and synapses. So since we are focusing on action potential, we have to look at the axon specifically. Inside the axon, an action potential takes place, and this is what it looks like. When there is an absence of input, most neurons have a stable potential of negative 70 millivolts. This is what is called the resting period, as you can see as labeled letter A. During this resting period, there are a lot more sodium ions outside of the cell than inside of the cell, and there's a lot more potassium ions inside of the cell than outside of the cell. Throughout the axon, there are sodium ion channels and potassium ion channels, but these are both closed during the resting period. When the neuron has a strong enough stimulus, it will push the potential to around negative 55 millivolts. This is called the gate threshold. When it reaches this threshold, the sodium ion channels open, allowing sodium ions to flood the axon. This is what you can see in letter B. When the potential hits negative 55, the sodium ion channels open, allowing the sodium to flood inside of the axon. This is an all or nothing phenomenon. It either happens or it doesn't. In the meantime, the potassium ion channels stay closed. As more sodium ions enter the inside of the axon, it becomes more positive. This is called depolarization, as you can see in letter C. Sodium wants to meet its equilibrium potential, which is about positive 30, because that is where it's the most comfortable. So when the potential gets more and more positive, this is called depolarization. When the potential hits positive 30, the sodium ion channels close. This is action potential, as you can see in letter D. Once the potential hits positive 30, the sodium ion channels close, allowing the potassium ion channels to open. The potassium ions then flood out of the axon. This is called repolarization, as you can see in letter E. Repolarization is when the potassium ions flow out of the axon, making the inside potential a lot more negative. Just like sodium, potassium wants to reach its equilibrium potential of about negative 80. When it hits negative 80, potassium ion channels close. This is called hyperpolarization. Hyperpolarization is when both channels are closed. Nothing goes on when the channels are closed because nothing can go through, but they're not closed enough to restart the process. They have to be completely closed to restart. After hyperpolarization, the channels eventually close, allowing the axon potential to start all over again in letter A. Let's review. At negative 70 is the resting period. At negative 55 is the threshold gate. As the potential gets more positive, that's called depolarization. At positive 30, that's action potential, and as it gets more negative, that's repolarization. Once it dips down to negative 80, that is hyperpolarization. Action potential takes place in one of two ways, either continuous conduction or solitary conduction. Continuous conduction is a much slower process because it has to go through the whole axon. Solitary conduction gets covered with a fatty insulator called the myelin sheath. In between the myelin sheath are uncovered parts of the axon called nodes of Ranvier. This term solitary comes from the Latin word jump. The myelin sheaths allow the action potential to jump from Ranvier to Ranvier, making the process a lot quicker. So there are two parts of your nervous system. There's the central nervous system and the peripheral nervous system. In the central nervous system, that is what makes up the brain and the spinal cord. The peripheral nervous system is what makes up everything else. In the central, there are these cells called the odendrocytes, and they make up the myelin, while in the peripheral nervous system, there are Schwann cells that make it up. If we are looking at the peripheral nervous system neuron, this is what it looks like. You can see the myelin and the nodes around VA. The cell body is where they pick up information, and the synapses is where it releases it. I hope this helps you understand axon potential a little more. Thanks for watching my video.